Data preparation, which involve data cleansing, joining and creating formula, has been done in Alteryx. This is the overall picture of the workflow to get the final data source from all three raw datasets. The data is now being summarized in three conditions of green, yellow, and red. Also, alert response is created based on the chloride, pH and iron reading value. Next, the overall pipeline condition is determined by combination of condition in previous slide, where 2 indicates worst condition, 0 indicates good condition and 1 indicates moderate condition. An interactive dashboard is created to display the results from the evaluation process by using Tableau. Tab 1, to show the overall condition of the pipeline. We are using tree map chart to visualize the condition on daily basis. Date filters are provided to assist the user, and indicator legend to show the tab 2, to show the details of chloride, pH and iron value. This tab will shown once the user select the tree map chart in the first tab. Average line also provided to guide the user.
Moving to Chapter 4, Statistical Inference.
In this table we show the data that the statistical analysis will be conducted at. From here it is very difficult to identify any trend, useful information. However, it still shows the painful truth that there are around 6,000 plus lives were lost every year, and over 400 to 600,000 car accidents happen annually. It shows the impact and importance of immediate effort to reduce car accidents, especially fatal accidents. The statistical analysis is started by performing a correlation analysis using Excel. From here we can see that motorcycle has high correlation with the number of deaths per year, which align with the common impression. However, the surprise fact here is the accidents that involved lorry actually has negative and low correlation with the fatal accidents. This is opposite of what people usually think, and further analysis will be conducted to verify if the result of the correlation is valid. R has been selected to be used as the tool to perform linear regression analysis for the motorcycle. From the result obtained from R we can clearly see that R returns same correlation value as Excel. Multiple R squared is 0.5003, adjusted R squared is 0.4378, and the p-value obtained is 0.02215. The regression equation we obtained here is y equals 5088 plus 0.0142x. The analysis of motorcycle will be continued with 95% confidence interval analysis. For every additional 1,000 motorcycle accidents happened, there will be additional average of 2.6 to 25.67 cat.
Next we will continue linear regression analysis for the lorry. From the result obtained from R we can see that the multiple R square is 0.0222, adjusted R squared is minus 0.1, and the p-value obtained is 0.6811. The regression equation obtained is y equals 5088 plus 0.0142x. 95% confidence interval analysis. For every additional 1,000 motorcycle accidents happened, there will be a mean in between 23 lesser or 16 more casualties happened. This poor results does not bring any significant value.
Next is Chapter 5, Predictive Analytics.
This is descriptive analysis result. This analysis represents the distribution of each individual variables. Skewness is a measure of symmetry, or more precisely, the lack of symmetry. The skewness value can be positive or negative, or undefined. The correlation coefficient is a statistical measure that calculates the strength of the relationship between the relative movements of the two variables. The range of values for the correlation coefficient bounded by 1.0 on an absolute value basis or between -1.0 to 1.0. The correlation coefficient is a statistical measure that calculates the strength of the relationship between the relative movements of the two variables. The range of values for the correlation coefficient bounded by 1.0 on an absolute value basis or between -1.0 to 1.0. If the correlation coefficient is greater than 1.0 or less than -1.0, the correlation measurement is incorrect. A correlation of -1.0 shows a perfect negative correlation, while a correlation of 1.0 shows a perfect positive correlation. A correlation of 0.0 shows zero or no relationship between the movement of the two variables.